Hi guys, my name is IBM and I am solving 970213 October November 2023. This is Physics 9702 paper 1. It's component 1-3. I hope you have enjoyed component 1-1, component 1-2. If you have followed my videos, the solved past paper questions which are grouped in topics or topical solved past paper questions, these questions are now going to be very easy. So without wasting time, let me take you to component 1-3 and we solve it. Okay, so this is component 1-3, October, November 2023. The paper is 1 hour and 15 minutes. So I will not waste time to go through the instructions. They are always the same. Total mark is 40. You can go through the document, the constants, the formula which are always provided. Question number 1. What is the best estimate of the wavelength of green light? Of course, green light is in the visible spectrum. Visible spectrum ranges between 7 times 10 to the power of -7. This is for red, up to 4 times 10 to the power of -7 meters. This is for violet. When you change this from meters to nanometers, this will be 700 nanometers, and this will be 400 nanometers for violet. So green is visible, so it is in that range. This is already above. This is already above. This is 2 below. So the answer is B. Green is between 700 nanometers and 400 nanometers. That is visible light. Non-electric field and ammeter reads 2 microamperes. In a second circuit, the ammeter reads 1 milliamperes. How many times larger is the current in the second circuit compared with the current in the first one? So in the first one, it is 1 times 10 to the power of -3 amperes. Divide by, in the second one, it is 2 times 10 to the power of -6 amperes. Micro is -6, milli is -3. So I'll just divide 1 exponent -3 divide by 2 exponent -6. That is 500. So the answer is automatically A, 500. A set of repeated measurements is made of a fixed quantity. An average of these measurements is calculated. An average. Remember, the average only reduces random errors, not systematic errors. What is the effect of averaging on the random error and the systematic error in the measurements? Taking an average does not affect the systematic error. It remains there. So what is the effect of averaging on the random error and the systematic error? Random error and systematic error are both reduced. Remember, that is not true. Systematic errors are not. Random error and systematic error are both unaffected. Random error is reduced. The random error is reduced, which is very true, but the systematic error is unaffected, so the answer is C. Taking an average reduces a random error. If you want to reduce a systematic error, you must first of all identify the systematic error by checking the zero error before using the instrument. So we cannot reduce the zero error by just taking an average. A boat is crossing a river in which the water is moving at a speed of 4 meters per second from left to right. Okay. In still water, the speed of the boat is 6 meters per second. The boat is directed at an angle theta to a line perpendicular to the river banks. The resultant velocity v of the boat is in a direction perpendicular to the river banks. What are the values of theta and v? Okay, so I'll just do a vector diagram here. So velocity of the water is in this direction, so I'll just complete this like this. This is the velocity of the water, which is 4 meters per second. This is v, this is 6 meters per second. So since this is multiple choice, I can use the cosine rule. So using the cosine rule, I will say 4 squared should be equal to 6 squared plus v squared minus 2 times 6 times v, the cos of theta. Or precisely, I have 16 should be equal to 36 plus v squared minus 12 v cos of theta. So I'll just check. I'll just check which pair gives me which pair gives me which pair would give me 16 on the left on the right hand side. So I want to check 36 plus v squared minus 12v cos theta to see which pair gives me 16. This should be equal to 16. So I'll just substitute. I have 36 plus v. V is 4.5. I'm checking part A, 4.5, but this should be squared, minus 12 times v, which is 4.5, cos of theta, which is 42. So you see this gives me 16. When I substitute, this gives me 16. So the answer is most likely going to be A. I can even check, if you can't do that, you can draw this to scale. If you want, you can draw this to scale. Let's say 1 centimeter represents 1 meter per second. So I'll draw a horizontal line of 4 centimeters. I'm using my ruler. You can also use your ruler. So I'm drawing a horizontal line of 4 centimeters. 4 centimeters on my ruler. This is rough. 4 centimeters. This is representing the velocity of the water in that direction. Then I'll draw a vertical line whose length I don't mind about. I'll just make it vertical, making 90 degrees. Okay? Remember, the velocity v should point in that direction. I don't know its magnitude. But if 4 centimeters starts from here up to here, I have to measure 6 centimeters from this point here. 6 centimeters represents 6 meters per second. So I'll put my ruler from this point here. I put there my ruler and I take it to the other line until I reach 6 centimeters onto the other line. Don't have enough space here. So I'm putting my ruler from where the 4 centimeters started from, but I'm projecting my ruler on the other line, which is vertical, to find 6 centimeters. So 6 centimeters is roughly stopping here. So if I prolong this line down, 6 centimeters stops there, so I just join these two. Okay, so this is 6 centimeters, 36 centimeters. So if I want to measure V, I just measure with the ruler from this point here up this point to see what V is in magnitude. So V is represented by, from my ruler, V is represented, because I didn't measure very carefully, it is represented as 4.6. So when I measure it is approximately 4.6, actually it is 4.7 centimeters, which is 4.7 meters per second. Because this is not to scale, this is drawing on a computer, it also takes you to V as being 4.5. The closest value there is 4.5. If you do this on a question paper, you should get very close to 4.5. Then I will put a protractor here to measure this angle here. And when I put my protractor to measure this angle, it is approximately 44 degrees. From my protractor, it is approximately 44 degrees. That means that also confirms that the answer is still A. Because I'm drawing on a computer, if you draw this to scale, 1 centimeter to represent 1 meter per second. First, draw the horizontal line to represent 4 meters per second. Use a protractor to draw a vertical line which makes 90 degrees with the horizontal line. Just make the line longer. Then project your ruler from where 4 centimeters started from and take it to the other line to make sure that it is 6 centimeters. Or you open your compass on the ruler for 6 centimeters, put it at where 4 is, where 4 starts from, and put an arc on the other vertical line. So it means the remaining thing is just to measure the distance between that point and that point to represent V. Remember, 1 centimeter is representing 1 meter per second, so that is fine. A student walks at a constant speed for a distance of 550 meters in a time of 40 seconds. So constant speed, that is a straight line for 40 seconds. Let's first check for 40 seconds. So here 40, it stops moving at with a constant speed for less than 40 seconds. So A is automatically out. Even here it stops moving at a constant speed for less than 40 seconds. So B is also out. It must continue moving at a constant speed for a distance of 50 meters in 40 seconds. So a straight line means constant speed for 40 seconds, constant speed for 40 seconds. So B and D, the first part is correct. Then the student rests for a time of 10 seconds. Let's see the resting time. I think this is 50. So that is 10 seconds. Resting time, I think this is also 50. 10 seconds, that is also correct. And then walks back to the starting point at a constant speed in a time of 30 seconds. I think if we check time of 30 seconds for both, time is fine. But this is a graph of distance against time. So even if you come back, the distance just increases, it actually doubles. If you move back, distance doubles, but displacement becomes 0. So since this is a distance time graph, C is going to be wrong. Because C is showing that total when he returns, distance goes to 0. Yet when he returns, total distance becomes twice. Because distance is a scalar quantity, it doesn't mind about the direction. So the answer is D. When you move towards and return back, distance is doubled. So total distance becomes 100. So the answer is D. The time taken for an object to fall from rest through a certain distance on Mars is Tm. The time taken for the same object to fall from rest through the same distance, so the distance is the same, h. The distance is the same. On Earth is Te. The acceleration of free fall on Mars 3.71. The air resistance is negligible on both Earth and Mars. What is the ratio Tm over Te? Since air resistance is negligible, the acceleration is constant. So I'll use S equals to ut plus a half at squared. So I'll start with the moon. S is equal to, starts from rest, initial velocity is 0, so this will be a half, times acceleration on Mars, which is 3.71. The time for Mars is Tm, and this is squared. Then on Earth, the distance, remember, was the same. Initial velocity is 0, so this is a half. The acceleration on Earth is 9.81. Then times the period on Earth, which is t, and that is squared. So I'll just equate the two equations. So s cancels, a half cancels. So I only have that 3.71 Tm squared is equal to 9.81 Te squared. So I want the ratio Tm over Te. But remember, these ones are already squared, so this is going to be 9.81 divided by 3.71. Then we shall find the square root of both sides. So when I find the square root of both sides, 9.81 divided by 3.771, then I find the square root of the answer. It's 1.63. So the ratio is 1.63, which makes the answer to be C. Which statement about mass is correct? Of course, mass is like opposition to change in motion offered by an object, or resistance to change in motion by an object, that is mass. Mass has magnitude and direction, that is not true. Mass resists change in motion. I think the answer is B. The greater the mass of the object, the greater the acceleration when falling in a vacuum. When falling in a vacuum, acceleration is constant. Here in a vacuum, acceleration is constant. So that statement is not correct. The mass of an object depends on its location. The mass is the same everywhere. A snooker ball has a mass of 200 grams, which is 0.2 kilograms. It hits the cushion of a snooker table and rebounds. That means it moves in opposite direction. The ball arrives at the cushion with a speed of 14 meters per second and then leaves it with a speed of 7 meters per second. The ball and the cushion are in contact for a time of 0.6. What is the average force exerted on the ball by the cushion? So remember, the resultant force is equal to the rate of change in momentum the mass is 0.2. The change in velocity is 14 minus -7 because it rebounds. Divide by the time of contact, which is 0.6. So I'll just check this with my calculator. 0.2 times 14 plus 7. Then divide by 0.6, which gives us 7. So the answer is automatically D. The ball falls from rest through air and eventually reaches terminal velocity. Remember, terminal velocity, the acceleration is 0. That means the resultant force resultant should be tending to 0. At terminal velocity, the resultant force is 0. What could be forces X and Y? So when it reaches terminal velocity, the resultant force becomes 0. So force Y should be the resultant force, because we see the resultant force is going to 0. The resultant force goes to 0, so Y should be the resultant force, not the weight. Y should be the resultant force. And if Y is the resultant force, then how about X? Of course, X is going to be the air resistance. Remember, the force due to air resistance is directly proportional to the speed squared. Until when the resultant force is 0, it means the force due to air resistance now cannot increase any further, so it becomes constant. When the resultant force becomes 0, the force due to air resistance now becomes constant. So that means Fx is the force due to air resistance. So it means, of course, the upthrust will be constant, so the answer is going to be A. X is the force due to air resistance and Y is the resultant force. For those who want more elaboration, the resultant force Fr is equal to the weight minus the force due to air resistance. The weight is constant. That's why B and D is still wrong. The graphs don't show constant force. So, as the force due to air resistance increases, the resultant force decreases. That means the force Y is the resultant force. And force X must be the air resistance. So the answer is automatically going to be A. An object X of mass 0.3 kilograms traveling in a straight line at a constant speed of 3 meters per second on a horizontal frictionless surface. Object X collides with a stationary object Y of mass 0.5. Okay. After the collision, X moves with a velocity 2.0 at an angle of 60 degrees with the direction before the collision. Object Y moves with a velocity V at an angle of 41 degrees to the direction of X before the collision as shown. What is the value of V? Okay, so I'm just going to conserve momentum. Let me just conserve momentum in the vertical momentum. Initially in the vertical, total momentum is 0 because the object one was stationary, another one was moving in the horizontal. So it means initially in the vertical there was no momentum. So total momentum in the vertical is 0. Then after the collision, Y is moving upwards. Y has a momentum in the vertical, which is going to be equal to the mass of Y times times velocity resolved in the vertical. This is going to be V sine of 41. X also has velocity in the vertical downwards, which is going to be 2 sine of 60. They're in opposite directions. So one will be positive, one will be negative. So for Y it is 0.3 sine of for Y it is 0. No, Y is 0.5. Y is 0.5 sine of 41 minus for X is the mass is 0.3 sine of 60 times V. The velocity is V. What am I doing here? Total momentum in the vertical inertia is 0. After collision, in the vertical upwards, we have the mass is 0.5 times V sine of 41. Then downwards, the mass is 0.3 times V, which is 2 sine of 60. So what is V? So making V the subject, V is going to be equal to 0.6 sine of 60 divided by 0.5 sine of 41. I'll just press my calculator. 0.6 sine of 60 divided by 0.5 sine of 41. So that is 1.6. So V is 1.6 meters per second. So the answer is C. A uniform rigid beam of length 3.2 is pivoted at its center. Two children sit at the opposite ends of the beam as shown. One child has a mass of 24, the other has 36. The heavier child causes end of the beam permanently rest on the ground so that the beam makes an angle of 20 degrees. What is the moment of the weight of the 24 kilogram child? So I need the perpendicular distance. So I'll just try to draw a line which makes 90 degrees with the perpendicular distance. Remember, the weight of the child acts vertically downwards like this, vertically downwards. And this weight will be 24 times acceleration due to gravity. It is acting vertically downwards like that. So I have to resolve the weight in this direction, in this direction here. So this angle here is automatically going to be 20 degrees. That angle is automatically going to be 20 degrees. If I take this one vertically downwards, this is 90. This is 90 minus 20. If this is 90, this is 90 minus 20. So this angle is going to be 20. So this angle is 20. So resolving the weight in this direction here, so that I have the perpendicular distance at 3.2, is going to be 24 times G. I think that will be cos of 20. It is the same as taking this along this line here. Okay, so the moment that we want, the moment is the product of the force times the perpendicular distance. The force is going to be 24 times G, which is 9.81 cos of 20, then times the perpendicular distance, which is now going to be 3.2. Okay, so this is going to be 24 times 9.81 cos of 20 times the perpendicular distance, which is 3.2 meters. So the answer here is going to be, did I do it right? .24 times 9.81 cos of 20 times 3.2. Oh no, I was taking the distance from one to the other. It is the distance from the pivot here, which will be this distance here. That is 1.6. So I'll just divide this by 2. So divide this by 2. That's 353. So this is going to be 353 Newton meters. The perpendicular distance from the pivot is 1.6. So the answer is going to be C. Two parts of a sailing boat are the mast and the boom. The mast is a vertical rigid beam and the boom is a horizontal rigid beam. One end of the boom is attached to the mast by the pivot. The other end of the boom is connected to the mast by a rope, as shown. The rope is at an angle of 40 degrees to the horizontal and exerts a tension T. Let's first resolve this tension to get the vertical force. So this is going to be T using 40 to be T sine of 40. If I want the force acting in the horizontal, but this force will act through the pivot, so it is useless. So but it will be T cos of 40. Because I want to take moments about the pivot, avoid using T sine 40 upwards equal to 200 down. There's a force at the pivot here, which should be catered for. So since I don't know the force at the pivot, I rather take moments about the pivot. What is the magnitude of T? So I'm just taking moments about the pivot. Sum of clockwise moments. T sine theta is going to cause anticlockwise, and 200 is going to cause anticlockwise. Okay, so let us assume the distance from the other end to the other end is L. And is it uniform? It is uniform. So it means its weight is at the center. So this is going to be a half L. So taking moments about the pivot, I will say that the T sine of 40, that is the force, times its perpendicular distance, which is L, should be equal to 200, that is the weight, times its perpendicular distance, which is L over 2. So L has cancelled, and it is going to be equal to 100 divided by sine of 40. 100 divided by the sine of 40. That is 155 or 156 or 160. This is 155 or 156. And the answers here, the closest is 160. So this is 160 to two significant figures. Full fat milk. Full fat milk is made up of fat-free milk mixed with fat. This is a past paper question. If you are very observant, you must have seen this earlier on. A volume of, if you have checked through my past paper questions for density, force, and pressure, it is there. A volume of this, of full fat milk, has a mass of 1.035 kilograms. It contains 4% of fat by volume. The density of fat-free is this. What is the density of fat? Okay, so let me begin by calculating the volume of fat. The volume of fat okay, if it contains 4% fat by fat, so it means the volume of fat is 4 over 100 times the total volume, which is 1 times 10 to the power of minus 3, which is 4 times 10 to the power of minus 5 meters cubed. That is the volume of fat. If I want that means the volume of, that is the volume of fat. Then the volume of fat-free. The volume of fat-free is therefore going to be just the difference between that 1 times 10 to the power of minus 3, then minus 4 times 10 to the power of minus 5. And I think this is just, this is direct. This is 9.6 times 10 to the power of minus 4 meters cubed. That is the volume of fat-free. Okay, let's first of all find the mass of fat-free milk. The mass of fat-free. Of course, mass is going to be equal to a mass is density times volume. So this is going to be equal to the density, which is 1.040 times 10 to the power of 3 times the volume, which is 9.6 times 10 to the power of minus 4, which is 1.04 exponent 3 times 9.6 exponent minus 4. So this is 0.9984, 0.9984 kilograms. So that means I can now find the mass of fat itself. The mass of fat, we shall just subtract. The total mass is 1.035. 1.035 minus 0.9984. So I say 1.035 minus the answer. So this is going to be 0.366 kilograms. No, there's a 0 here. 0.0 366 kilograms. That is the mass of fat. So I now know the mass of fat. I know even the volume of fat. So I can find the density of fat, which will be the mass 0.0366 kilograms divided by the volume of fat, which is 4 times 10 to the power of minus 5. So I'll just divide this by 4 exponent minus 5, which is 915. 915 kilograms per meters cubed. So the answer is going to be B. 9.15 times 10 to the power of 2 kilograms per meters cubed. Which expression for pressure is correct? Of course, pressure is force acting normal per unit area. A wooden cylinder floats partially submerged in a bath of water. Force F is applied to the cylinder until it is just fully submerged. What is not correct? Since the upthrust is going to be depending on the density of the liquid, of the water, times the volume submerged times G. So the question is, which statement is not correct? Some of the water gains gravitational potential energy. Of course, the water rises, so that one is true. mgh, the height of the water rises, so it gains gravitational potential energy. The cylinder loses gravitational potential energy because the cylinder is moving downwards. Its vertical height from the bottom is decreasing. So mgh for the cylinder h, the vertical height of the cylinder decreases. So this is also a correct statement. Work is done by the force on the cylinder F. Work is done by the force on the cylinder. Because the force is causing the cylinder to move a distance downwards, the work is done. So it means the statement which is not correct is D, which work is done by the upthrust on the cylinder. The upthrust force is not causing the cylinder to move, is not moving the cylinder, so there's no work done by this upthrust force. So the answer is going to be D. However, we would say work is done against the upthrust force. The system has useful power output 4 watts and wasted 16 watts. That means total power is going to be 4 plus 16, which is going to be 20 watts. What is the efficiency of the system? So efficiency is going to be the power output, which is useful, over the power input. So this is going to be 4 divided by 20 times 100. So 1 over 5 times 100, I think this gives us, is it 20%? 1 over 5 times 100, I think this is 20%. So the answer here is going to be B. A parachute is falling towards the ground at a constant speed. Acceleration is going to be 0 if we consider constant speed. The rate at which she is losing gravitational potential energy is R. Okay? So since it's moving at a constant speed, then the distance, which is going to be called the vertical height through which it moves, is going to be V times T. That is H is V times T. Then remember, potential energy is equal to mg times h. That means the rate, which is called R, is going to be mgh divided by the time. That is the rate at which potential energy is being lost. So it means R is going to be mg over t times h, which h is v times t. So t cancels out, making R, or making, we are making, what is the mass? So we are making m the subject. So m is going to be R divided by g times v. We now make m the subject. So the answer is going to be B. A copper wire of diameter 1.6 millimeters is stretched within the limit of proportionality. So it means F can be equal to Kx, or Young modulus is equal to stress over strain. So Young modulus is stress, which is force over cross-sectional area. Then times, we want to find the strain, so divide by the strain, which I will say times 1 over the strain. It is stress over strain, so it is stress times 1 over strain. So what is the strain? We have diameter. We also know that area is equal to pi d squared divided by 4. So when I make strain the subject, the strain is going to be equal to force over area times Young modulus, which is the same as 4F over pi d squared times E. Now we'll just substitute down here. So the strain is going to be 4. The force is 430 divided by pi, and D is 1.6 times 10 to the power of minus 3, but this is squared, then times the Young modulus, which is 130 gigapascals, that is times 10 to the power of 9. So it is 130 times 10 to the power of 9. Okay, I'll start by pressing the denominator. 130 exponent 9 times pi times, open brackets, 1.6 exponent minus 3, and this is squared. Then I'll get 4 times 430, and I divide this by my answer. So I'm getting 1.65, or 1.6 times 10 to the power of minus 3. 1.6 times 10 to the power of minus 3. Of course, this has no units, so the answer is C. Compressive forces are applied normally to the end faces of a cylinder of initial length L. The cylinder is compressed by the forces so that L decreases to 0.6 L. So original length is L, the new length is 0.6 L. After the compressive forces are removed, the cylinder's length increases to 0.8 L. So it's like it has been compressed beyond the elastic limit or the proportionality limit. But if the cross-section area is remaining constant, it has been compressed beyond L. It means it has undergone both elastic deformation and then plastic. If it increases in length when the force is removed but doesn't go back to its original length, it means it underwent elastic deformation before reaching the elastic limit, and then beyond the elastic limit it underwent plastic deformation. So the answer is going to be A. What describes the deformation of the cylinder when its length was 0.6 L? So when we compress it up to 0.6 L, we compress it beyond its elastic limit. So it underwent both elastic and plastic. So the answer is A. When sound travels through air, the air particles vibrate. A graph of displacement against time for a single air particle is shown. Remember, the gradient of a velocity displacement time graph is equal to the velocity. So here the gradient is 0, so velocity here should be 0, velocity is 0, velocity is 0, velocity is 0, velocity is 0. So it means if I sketch a graph of velocity against time or speed against time, then it should be starting from 0. So which graph shows how the kinetic energy, remember kinetic energy is equal to half mv squared. So kinetic energy is directly proportional to the speed squared. When the speed is 0, the kinetic energy is 0. So at t equals to 0, the speed is 0. Because we see that this is the tangent here is going to be a horizontal line. So v here is 0 at t equals 0. So the graph should start from the origin. The kinetic energy is initially 0. So this is wrong because it's showing at t equals to 0, kinetic energy is not 0. C is also wrong because at t equals to 0, kinetic energy is not 0. So we have to choose between B and D. So let's come back again. At a half a cycle, the speed is again 0 because it has reached maximum displacement. Let's check at a half, at t. After one period, the kinetic energy goes to 0. Let's check. In both it is 0, so we can't use that. Let's use half a period. Let's check half a period. Half a period, the kinetic energy is still 0. So here, half a period, the kinetic energy is maximum, yet the speed goes to 0 here. So it means B is out. And that means at half a period, the kinetic energy goes to zero because the speed is zero. So the answer is going to be D. I'm saying the gradient is the speed. For a displacement time graph, the gradient is the speed. And remember, kinetic energy is equal to half mv squared. When the displacement is maximum, the speed is zero. That's why I have written here v0, v0, v0 at the peaks. The speeds are zero at the peaks when the displacement is maximum. So the answer is D. A wave travels on the surface of water. P, Q, R, and S are four particles of water on the surface. The diagram shows the positions of the particles at one instant. The direction of the travel of the wave is from left to right. That means if it's from left to right, this particle must be vibrating downwards. And after that, these particles should be vibrating upwards, upwards up to the crest, the trough there. Then these should be vibrating downwards, downwards up to the crest, then upwards, upwards until reach the trough, downwards, downwards until reach the crest. Which two particles are about to move upwards? Okay, about to move upwards. So P is about to move downwards, and R is automatically moving downwards. So it is Q and S. So the answer is going to be D. Q and S. A loudspeaker emits sound of frequency Fs. The loudspeaker is attached to a car that moves with increasing speed. The speed is increasing. Directed towards the observer. If it is towards the observer, remember the observed frequency is going to be equal to V divided by V minus speed of the source times F of the source. So V is constant, F of the source is constant. But the speed Vs is increasing. If the speed of the source is increasing, it means the denominator V minus Us is actually decreasing. If the denominator is decreasing, it means F naught must be increasing. So let's see the question. Which statement describes the frequency of the sound heard by the observer? A frequency greater than Fs and increasing. So the answer is A. The frequency is automatically greater than Fs because it's moving towards. But because the speed of the source is increasing, then the frequency must be increasing. The frequency must be increasing. When Vs becomes bigger, the difference becomes smaller. When you divide, you get a bigger value of F naught. So the answer is A. Which statement about electromagnetic waves in a vacuum is correct? So we know that they all travel at the same speed. Amplitude is inversely proportional to velocity. For all waves, amplitude is inversely proportional to velocity. There is no such a statement. That is not true. Frequency is inversely proportional to wavelength. We know that V is equal to lambda times F, and V is constant for all waves, which is C. So C is equal to lambda times F. So lambda is inversely proportional to F. I think this is the correct answer. Intensity is proportional to amplitude. That is not true. We know that I is proportional to amplitude squared. Velocity is proportional to wavelength. Velocity is proportional to wavelength. Remember, velocity is constant. It is C. So it is not proportional to wavelength. The speed is constant. So the answer is going to be B. A vertically polarized electromagnetic wave of intensity I naught is instantly normal on a polarizing filter. The transmission axis of the filter is at an angle of 30 degrees to the vertical. The transmitted wave from the first filter is then incident normally on a second polarizing filter. Let's first deal with the first one. So for the first one, we know that intensity I is equal to I naught cos squared of theta. So what comes from the first filter? Let me call that one I1. From the first filter, the intensity, if we call it I naught, the angle between the vertical and the axis of transmission is 30, so it will be I naught cos squared of 30, which is, I think cos squared of 30 is 3 over 4. If we square, let's check. Cos of 30 but squared, it is 3 over 4. So this is 3 over 4 of I naught. So what leaves here is 3 over 4 of I naught is what is going to the second one. So what is coming here is I1. So I2 is what emerges from the other side. Let me call it I2. I2 should be equal to I1 cos squared of the angle theta. So it is rotated. The transmission axis of this filter is at an angle of 50 to the vertical. So since this one is at an angle of 50 to the vertical, then it means on 90 degrees, I must add 30. So it has been rotated through 30 plus 90, which gives us 120. So I2 is going to be I1, which is 3 over 4 of I naught cos squared of 90 plus 30. So I'll say cos of 90 plus 30, which is 120, then squared, then times 3 divided by 4. So this is giving me 0.1879. So I2 is going to be 0.19 times I naught. So the answer is C. Which statement concerning stationary waves is a stationary wave is correct? All the particles between adjacent nodes oscillate in phase. I think we mentioned that that is true. If these are two nodes, this is a node and this is a node. Particles in between two nodes will always vibrate in phase, but they will be out of phase with the particles in the neighboring antinode. So here they are in phase. Particles here are in phase with each other, but they are 180 degrees with particles in the neighboring segment. So the answer is automatically A. A stationary sound waves can be formed in the air columns of pipes. One type of pipe is closed at one end and open at the other end. Another type is open at both ends. Which pipe can form a stationary sound wave with the lowest frequency? Okay, so let's check just the fundamental mode. So I will draw the fundamental mode of an open pipe. So here length is a quarter plus a quarter. This is equal to a half of wavelength. So fundamental frequency is going to be V over lambda, which is V over, here lambda is going to be equal to 4L. So this is 4L. Then I draw the fundamental mode here. This is a quarter of a cycle. So 2L is equal to a quarter of wavelength, which means the wavelength is going to be equal to 8L. So the frequency here is going to be V over wavelength, which is 8L. And let's check here. Then this is going to be just like this. So here L is equal to a quarter plus a quarter, which is a half of wavelength. So wavelength here is 2L. So the frequency here is going to be V over wavelength, which is 2L. Then this one, this is a quarter cycle. L represents a quarter of a wavelength, so wavelength is equal to 4L. So the frequency here is going to be V over 4L. So let's compare. Of course, this one and this one are the same. So the question is, which pipe can form a stationary sound wave with the lowest frequency? Of course, the lowest frequency is this one here, because you see it is V over 8L. So the answer is going to be B. Water waves in a ripple tank are made to pass through a small gap. Remember, diffraction is maximum when the wavelength is approximately the same as the size of the gap. Okay. So which diagram shows the waves after they have passed through the gap? Of course, this cannot be diffraction. They spread inwards towards the source where they're coming from. And let's first of all compare the wavelength and the size of the gap. So if I try to measure this distance and compare with this, they are almost the same size. So diffraction must be maximum. So C is wrong and D is wrong. So the answer is going to be A. Because when you try to measure this length here, It is almost the same as the size of the gap. So that means the bending must be maximum. So the answer is the correct way of bending is going to be A. So the answer is A. Because diffraction is maximum when the wavelength is approximately the same as the size of the gap. You can try to measure and see if it is approximately the same. Light of a single wavelength exists normal on a double slit. The slit separation can be varied. A screen is placed a fixed distance away from the double slit. The screen and the double slit are parallel. A particle of bright interference fringe is observed on the screen. Remember, it is a double slit. If it is a double slit, the first thing to come into your mind is wavelength equals AX divided by D. Now, they have given us graphs of X against A, so I make X the subject. So X is going to be equal to lambda times D divided by A. So you notice that X should be inversely proportional to A. So it means D is wrong and B is automatically wrong. As A increases, X should be decreasing. But let's check. When A tends to 0, if A is 0 or is becoming 0, what is X going to be? X is going to, when I put 0 here in the denominator, X tends to infinity. That means the graph should not touch the X axis. So it means C is wrong because C shows the graph is turning towards the vertical, yet X should be turning to infinity. The graph does not touch the Y axis, it doesn't touch the X axis, so the answer is going to be automatically A. You can check, when I make A the subject, A will be inversely proportional to X. And when X tends to 0, it means A is tending to infinity. So this graph must be asymptotic to the axis, doesn't touch any of the axis, so C is wrong. I'm saying C is wrong because when you prolong the graph, it will touch the axis. Yet for A, when you prolong the graph, they don't touch the x-axis or the y-axis. A diffraction grating is used to measure the wavelength of light. The spacing of the slits in the grating is 1.15. The first thing that comes into your mind when you see diffraction grating, you know that a diffraction grating is given by n lambda is equal to d sine of theta. So what is the wavelength of the light? So theta is the angle measured from the center. So this is going to be 30 degrees. So the wavelength is going to be d. What is d? D is 1.15. D is 1.15 times 10 to the power of minus 6 sine of 30 divided by, it is the first order, so this is divided by 1. So I'll just say 1.15 exponent minus 6 times sine of 30. So it is 5.75 times 10 to the power of minus 7 meters, which is of course 575 nanometers. You can check, just divide this by 1 exponent minus 9. It is 575 nanometers. So the answer is going to be C. What could not be used to create an electric current? Of course, an electric current is the rate of flow of charge carriers. There should be charge. Alpha particles have charge, beta particles have charge, neutrons do not have charge, protons have charge. So C. You can't use neutrons to create an electric current because they have no charge. What is the definition of potential difference? We know that V is energy per unit charge, and this energy is from electrical to other forms. So it is energy transferred per unit, energy transferred per unit charge, the energy transferred per unit current. So the answer is A, energy per unit charge. The resistance of a filament lamp increases as the current in it increases. Let's sketch the graph for a filament lamp. The IV characteristic graph of a filament lamp, remember, it has a decreasing gradient. It is a decreasing gradient, and the resistance is equal to 1 over this gradient. What is the reason for this? Why does it have a decreasing gradient? The decreasing gradient means the resistance is increasing. And resistance is increasing because resistance is directly proportional to temperature. The temperature of the filament lamp must be increasing. So the answer here is automatically the temperature of the filament increases. And if the temperature increases, the resistance also increases. That's why the graph is having a decreasing gradient. A battery of EMF 12 volts and negative internal resistance is connected to the fixed resistor of resistance 40 ohms and a thermistor of resistance RT. Initially, the temperature of the thermistor is 15 degrees Celsius and the current is 0.1 ampere. That is initially. Let's find the PD across the 40 ohms. So we know that V across the 40 ohms is going to be equal to the current times 40, I times R. This is going to be 0.1 times 40, which is going to be 4 volts. That is initially, which means the PD across RT is going to be 12 minus 4, which is going to be 80 volts. I'm trying to find, so initially the other one is the PD across 40 ohms is 4 volts and the thermistor is 80 volts. That is initially. The temperature of the thermistor then changes, which causes the current to be 0.12 amperes. So it means the PD across 40 ohms is going to be 0.12 times 40, which is, I think this is going to be 4.8 volts, which means the PD across the thermistor RT is going to be 12 minus 4.8, which is, I think this is 7.2 volts. So what is the question? How does the temperature of the thermistor change? And what is RT at the new temperature? So RT at the new temperature must be VT at the new temperature is 7.2 volts. What is RT? So RT is going to be V over the current, which is going to be 7.2 over the current, which is 0.12. I think this is divisible. That is, I think 60. 7.2 divided by 0.12, 60. So the PD at the new temperature is, the resistance of the thermostat at the new temperature is 60 ohms. So we ignore C and D. Okay. Now the resistance for both it is 60. But what has happened to the temperature of the thermistor? What has happened to the temperature of the thermistor? Okay, I can find the initial resistance to see if it has increased. But if the PD across the thermistor has increased, the PD across the thermistor has decreased. The PD across the RT has decreased, or it goes down. It goes from 8 to 7.2. It means the resistance across the thermistor has gone down. So it means the resistance of the thermistor has gone down. And if the resistance of the thermistor goes down, remember resistance of the thermistor is inversely proportional to temperature. The resistance of the thermistor has gone down because the PD across the thermistor is low, because the temperature has gone up. So it means the answer is automatically A. A cell of EMF 3 volts and internal resistance 0.5 ohms is connected to a variable resistor, a voltmeter and an ammeter as shown. The resistance of the variable resistor is varied. Okay, the reading on the ammeter I and the reading on the voltmeter V are recorded. Which graph shows the variation with I? Okay, so remember V is equal to I times R. Let's check. When we have maximum current, of course we shall have maximum current when the resistance here, we'll call this one R, equals to, it can vary from 0 to any value. So if R goes to 0, it means the current is going to be equal to V, which is 3 divided by 0.5. And this is going to be, I think this is 6 amperes. The maximum current should be 6 when there's a short circuit. When the variable resistor is 0, there's a short circuit. There's a maximum current in the circuit, which is 6 amperes. So the maximum current should be 6 amperes. The maximum current should be 6 amperes. I ignore B because it's showing the maximum is 0.5. I also ignore D because it's showing that the current maximum is 3. So I have to choose between A and C. When there is no current being supplied, if R is equal to 0, I is equal to 6, that is short circuit. Short circuit, so I maximum is 6. But when there is no current, when I equals to 0, when there is no current being delivered in the circuit, then the reading of the voltmeter must be the EMF. Then V should be equal to the EMF, which should be 3.0 volts. When there is no current being delivered, the reading of the voltmeter is the PD across the terminals of the cell, which is going to be the same as the EMF, which should be 3 volts. So that means our answer is automatically C. When the current is 0, the V is the EMF. And the maximum current is going to be 6.0 when the PD across this one is 0, because if R is 0, V is equal to I times 0. When V is 0, the maximum current is 6, so the answer is going to be C. 3 resistors R1, R2 are connected in parallel to a cell. The current in the resistors are I1, I2, and I3. The PD across are V1, V2, and V3. The current in the cell is I0. The PD across the cell is V0, as shown. Which equation can be obtained by Kirchhoff's second law to the circuit? Let's apply Kirchhoff's second law. If I apply it here, I can also apply it here. I can also apply it here. I'm choosing the same direction. So here, the EMF is V0. The PDs, there's only one PD, which is V1, and the current is in the same direction as the loop. So this is equal to V1. Let's apply it here. There's no battery, so the EMF is 0. Then the PDs, we notice that V1, which is for R1, is in the opposite direction to the current is in the opposite direction to the loop. So this is going to be negative V1. But V2, the current through the resistor R2 is in the same direction as the loop. So this is going to be positive V2, which means V1 is the same as V2, which also means V1 is the same as V2, which is the same as V0. Let's go to the third one. There's no battery here, so the EMF is 0. But the R2, the PD in R2 is in the opposite direction to the current, so this is going to be minus V2 plus I3 is in the same direction as the loop, so the PD V3 is positive, so this is plus V3, which means that V2 is equal to V3. But remember, V2 was equal to V1, which was equal to V0. So it means V3, which is the same as V2, is the same as V1, which is the same as V0. So the answer to this question is going to be precisely C. 3 resistors, each of resistance R, are connected in a network as shown. The total resistance between X and Y is 8. What is the value of R? So these two are in series, their total is going to be 2R, but then they're in parallel with R. So total resistance is going to be R times 2R divided by R plus 2R. That is product over the sum. This is going to be equal to 8. So that is 2R squared divided by 3R is equal to 8. 1R cancels. So we have that R is going to be 3 times 8 divided by 2. That is 24 divided by 2, which is equal to 12 ohms. So the answer here is going to be D. A potentiometer and a driver cell of EMF E are used to measure the EMF of a new cell. A sliding contact of P at P is moved along a resistance wire. The reading on the galvanometer is 0. Okay. So the reading of the galvanometer is 0 when the pointer is here. What is an essential requirement for the EMF of the new cell to be measured accurately? A potentiometer and a driver cell of EMF E are required to measure the EMF of a new cell. A sliding contact at P is now moved along resistance wire QR until the reading on the galvanometer is 0. Okay? What is an essential requirement for the EMF of the new cell to be measured? Remember, the PD across QP should be the same as the EMF of the cell. And I think the negative terminals are joined here, the positive terminals at the other end. So remember also that the E should be greater than the EMF of the driver cell of the new cell. The driver cell is always greater than the EMF of the new cell, of the cell whose EMF is to be measured. So the EMF here should be smaller than this. That is 1. The contacts should be connected like that. Okay, let's see the options. The EMF of the driver cell must be less than. That is not true. It should always be greater than. It should be greater. The galvanometer must have a large resistance. Of course, this doesn't apply. After all, it is going to read 0 when there is a balance. The internal resistance of the new cell must be 0. So this one is not connected to EMF at all because we just need balance. The resistance per unit length of the wire QR must be constant. I think this is very true. Remember, the PD across QP is going to be the same as the EMF of the cell, which is going to be I times, or which is going to be equal to the constant times, because the resistance per unit length is going to be constant. So this is going to be I, the current I, times the constant K, which is going to be times R. But R is going to be the constant times the length L. So we need the resistance per unit length. The constant K is the resistance over L, resistance per unit length. If I want the resistance PQ or QP, I need the resistance per unit length times the length PQ or QP. So the resistance per unit length should be constant. So the answer is D. The table shows the number of nucleons and the total number of particles, protons, neutrons, and electrons in a neutral atoms of 4 nuclides, W, X, and Y, and Z. Which 2 nuclides are isotopes of each other? So let's first find the total number of protons. Protons plus neutrons is giving us this. But we also have plus electrons. So number of electrons, so let me add here electrons. The number of electrons here is going to be 30 minus 19, which I think it is 11. The number of electrons here is going to be 31 minus 19, which is 12. The number of electrons here is going to be 32 minus 21, which is 11. The number of electrons here is 31 minus 22, which is 9. Remember, the number of protons is the same as the number of electrons. So this one has 11 protons, this one has 11 protons, 12 protons, 9 protons. Which ones are isotopes? Same number of protons, which is this one and this one. So that is W and Y. So the answer is going to be B. When a sample of radioactive isotope decays by alpha emission, the alpha emitted have a single discrete energy. When a sample of radioactive isotope decays by beta minus emission, beta minus particles are emitted with a continuous range of energies. The explanation for the continuous range of energies was that the beta particles are accompanied by other particles such as the electron neutrino or the electron antineutrino. What is the explanation for this? So I think the answer is automatically A. An antineutrino is emitted with beta minus. I think that is true. Beta minus is a normal particle. It is accompanied by an antineutrino. Beta plus is an antiparticle is accompanied by a neutrino. So beta plus neutrino, beta minus antineutrino. So an alpha particle is emitted with an antineutrino is emitted with an alpha particle. This is not true. Alpha particles have much more energy than beta. This doesn't relate. Beta minus have much more energy than alpha. This doesn't relate. So the answer is going to be A. And lastly, some particles are a combination of 3 quarks. Which combination of quarks does not result in a particle with a charge of positive 1.6? This is positive E. So up, down, down. This is of course 0. Remember up, top, and charm. These ones have a charge of positive 2. It is plus 2 over 3 E, which is, and then down, strange, and bottom, these ones have minus 1 over 3 times E. So this one is 2 over 3E plus 1 over negative 1 over 3E plus negative 1 over 3E, which gives you 0. So this is not true. Up, strange, strange, it is the same as the first one. Plus 2 over 3E minus 1 over 3E minus 1 over 3E. This one is 0. So it means this is also out. Up, up, down. So this is 2 over 3 plus 2 over 3. This is times E minus 1 over 3E, which gives us plus E, which is which combination of quarks does not result in a particle with a charge of plus 1 over 6 plus 1.6 or 0? So this one has given us 0, this one has given us 0. And this one is plus E, which is 1.6 times 10 to the power of minus 19 coulombs. So this is correct. Up, up, up is 2 over 3E plus, well, we just multiply this times 3. 2 over 3E plus 2 over 3E times 3. This is going to be 6E over 3, which is 2E. So 2E is 2 times 1.6 times 10 to the power of minus 19. So the answer is D. The rest, they either give you 0 or plus 1.6 times 10 to the power of minus 19. So the answer is D. Okay, I think I've tried to keep time, and that marks the end of October, November papers. I recorded them all from February, March, May, June, and then October, November 2023. So I think 2023 is covered for AS and A level. I'll try to cover paper 5s. See you until next time. Bye bye. Love you.